Hi there, Samina. This is Kelly. Thank you for sending these problems to me. Before I explain these problems on this page, there's some notes I need you to take. So if you can get just a blank piece of paper, please. There's 3 concepts I'd like to go over with you. Okay? So there's going to be 3 concepts we're going to talk about. And so concept number 1, I'm going to talk about geometric motion. Geometric motion. Topic number 2, I'm going to talk about triangle classification. Topic number 3, I'm going to talk about the triangle sum property. So these are the 3 topics I'm going to go over before I explain the problem. So if you have a notebook or a pen and paper, that would be good so you can write down these notes. Again, topic 1, geometric motion. Topic 2, triangle classification. Topic 3, triangle sum property. Okay, topic number 1, we're going to talk about what's called geometric motion. There's 2 main types of geometric motion. Those 2 types are what's called rigid and non-rigid. Rigid motion, there's no change of shape. There's no change of shape. Non-rigid, there's a change of shape. That's S-H-P-E. Rigid, there's no change of shape. Non-rigid, there's a change of shape. So first I'm going to talk about the rigid motions, which are the ones mentioned in your notes. There's 3 of them. The rigid geometric motions. When I say motion, there's another word. They're also called transformations. So there's 3 rigid transformations. And I'm going to explain all 3. One of them is called translation. Now, I'm going to give you both the technical name and then like an American slang for it. So the technical name, translation. The slang is going to be slide. Then you have something called reflection. And the slang I'm going to give you is flip. And then rotation. So the 3 geometric rigid transformations, which means motion, transformation, same thing. The 3 of them, they're called translation, reflection, rotation. Translation, reflection, rotation. I'm going to give you an example of each. So translation means you take a shape, so draw yourself. I'm going to be very careful here to draw a triangle. I'm going to make it a right triangle so it's easy to watch this move. A translation is where you just slide the image over, so it slides left, right, up, or down. But you still get the exact same image. It doesn't change shape. It stays the same shape. That's called translation. You just slide it left, right, up, down. That's called translation. Then you have reflection. So if I take any shape, pretend that's a mirror, and I show it in a mirror, or you flip it over, that is called reflection, like reflection in a mirror. So I'm flipping over like a mirrored image. Translation, you slide. Reflection, you flip. And you have your last rigid motion, which is called rotation. That's where you take a triangle and then you imagine like that as a pivot point, and you rotate it around a certain point. So far we have translation, reflection, rotation. And those are all called rigid transformations. Rigid transformations. Rigid transformation means they do not change shape. They stay the same size. No change in shape. Then you have what's called a non-rigid transformation. And there's only one, and it's called a dilation. Dilation is when you change in size. So let's say I have this triangle, and notice it's 2 units by 3 units. If I dilate by 2, in other words, I multiply it, then it changes in size, and I get a triangle that would be 4 units by 6 units. This new triangle, you can see it's the same shape, but it's a different size. That's called a non-rigid transformation, also known as a dilation. Okay, so I told you there'd be 3 things that we talk about. That first one was geometric motion. Number 2, we're going to talk about triangle classification. Okay, triangle classification. You can classify triangles 2 different ways. 1, you can classify them by their angles. And 2, you can classify them by their sides. I'm going to draw an example of each classification. I'm going to be quiet a moment. All you want to do is just copy down, and then I'll happily explain. Okay, this first one is called an acute triangle. The second one is called a right triangle. This is called an obtuse triangle. And this is called equiangular triangle. If you need to, pause the video to write this down. So just draw and write the words. I'll go over and explain them in just a moment. Over here, under sides, just draw and write these down. Okay, if you need to, pause the video until you have all of these drawn with the definitions written down. Now I'm going to explain what each one is. So there's 7 different types of triangles. There's 4 different ones classified by angles and 3 different ones classified by sides. Now I'm going to explain each one. An acute triangle is when all the angles are less than 90 degrees. So all the angles less than 90 degrees. That's an acute triangle. A right triangle is a single angle at 90 degrees. A single angle at 90 degrees. An obtuse triangle has a single angle that's greater than 90. A single angle that's greater than 90. An equiangular is when all 3 angles are equal. And we usually show that by 60s for all 3, or we do the sweep with these hatch marks to represent that they are all of equal measure. So that's the 4 ways to classify triangles by their angles. Acute, everything's less than 90. Right, one angle is 90. Obtuse, one angle bigger than 90, larger. Equiangular, all 3 angles are equal and measure 60 degrees. Okay, classifying triangle by their sides. Scalene means none of the sides are of equal length. You have a shorter, a medium, and a longer side. None of them are equal. That's scalene. Notice the hatch marks don't match. Then you have isosceles. Isosceles is when you have 2 equal sides. Notice the little hatch marks, they mean that 2 sides are equal. Equilateral means all 3 sides are equal. Now, you can classify triangles using both classifications. I'm going to give you an example. If you could draw this triangle down below, I'll give you an example of how we name them. This triangle right here is a right isosceles triangle. It's a right triangle because it has a right angle. It is isosceles because it has 2 congruent sides. So that's classifying a triangle by both its angles and its sides. Okay, that's concept number 2. The last one is the triangle sum property. This is a simple one. Whenever you have a triangle on a flat surface, the 3 angles will always add up to 180 degrees. Whenever you have a triangle on a flat surface, it has to be on a flat surface, like a piece of paper. Flat surface. All 3 angles, that's my symbol for angles, 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 add up to 180 degrees. So let's recap. Geometric motion, you have 2 of them, rigid and non-rigid. The rigid transformations are translation, reflection, rotation, also known as slide, flip, turn. You have your non-rigid transformation, which is dilation. Dilation means to change in size, bigger or smaller. Then we classify triangles by both their angles and by their sides. Acute, right obtuse, equiangular. Sides, scalene, isosceles, equilateral. Okay, now that we have those concepts reviewed, let's take a look at these. Okay, so it says describe the transformation. Now remember, there's 4 transformations possible. Let's list them. I'll type them so it's easier for you to read. Okay, the 4 transformations are translation, remember, which means to slide, reflection, which means to flip over something, rotation, which means to turn, and dilation means to change in size. In this case, it's pretty easy to see that moving from this triangle A, B, C to what's called A prime, B prime, C prime, it's easy to see that this was a turn or a rotation. Now this one says reflect across AB, reflect the segment AB across line M and then across line N, knowing that M and N are parallel. So just to reinforce here, parallel means they never intersect. They're always going the same direction. Put the little arrow feathers on there, that means parallel. Now reflect means like a mirror. So if I reflect across this line, I imagine what would it look like if I were to mirror it? And it would look something like this. And then it wants you to reflect again across N, so I imagine I take this and I flip it over N and I try to make it the exact same distance but just flipping over like a mirror. So I reflect here from there to there, and then I reflect again, this image going this way. You're going to notice here that the original image, number 1, is the same as image number 3. So whenever you reflect across parallel lines, a set of parallel lines, the original and the final results will be the same thing. Okay, it says classify it by its sides and by its angles. Now by its sides, remember there are 3 of them: Scalene, Isosceles, Equilateral. Angles, there are 4 of them: Acute, Right, Obtuse, Equiangular. Okay, now in order to do this, first thing we need to do is we need to find the measure of this last angle. So you see right here, this is 60 degrees, this is 50 degrees. We're going to call this X. And we know that the 3 angles of a triangle must add up to 180 degrees. So I'm going to set up this equation here. 60 degrees plus 50 degrees plus unknown degrees equals 180. I'm going to add 110 plus X equals 180. And now I'm going to minus both sides. And 110 minus from 180 is going to be 70 degrees. So this is now 70 degrees. So we take a look. We're going to classify first by the angles. All 3 angles are less than 90. So we know Okay, Samina, somehow your original diagram was incorrect, because when I just solved, this third angle has to be 70 degrees. And if I have 3 different angles, these sides should be different. Okay? Right now, you have an 8 and an 8, which means they're the same. So if there's the same, it would be isosceles. But if it was isosceles, you should have 2 equal sides. So let me give you an example of an acute isosceles triangle. The triangle you have, it's defective in how it's copied down. So let me give you an example that would be true. Okay, isosceles would be 2 equal sides, and if you have 2 equal sides, you also must have 2 equal angles. For example, if you had 50 degrees and 50 degrees, this would be an example of an acute isosceles triangle. An acute isosceles triangle. Okay, so for these problems here, this first one is based on the simple fact that the 3 angles of a triangle on the inside adds up to 180 degrees. So we write it down like this: angle plus angle plus angle equals 180. Therefore, we're going to go 70 plus 85 plus an unknown angle x equals 180. We add these up, and that's 155 plus x equals 180. And we minus 155 each. So our unknown angle is 25 degrees. Okay, this last one, there's one more concept I didn't go over with you, so put this in the margin, please. There's Samina, I appreciate it. Remember the 3 angles of a triangle. I'm going to color code them. I have green, blue, and red. That those 3 angles have to add up to 180 degrees. Now, there's an additional property called an exterior angle. And that happens if you stretch out a side. This yellow angle and the green angle also have to add up to 180 degrees because it's a straight line. So again, I'm color coding. We know that the green plus the yellow also adds up to 180. So since the 180 is the same, we can do this. We can eliminate, and we can do this, that the red plus the blue plus the green equals the yellow plus the green. And in algebra, when you have the same thing on both sides, you can just simply cancel. So you see here that the red angle plus the blue angle have to add up to that yellow angle. What this is saying is anytime you have an exterior angle it's going to equal the sum of the two angles that are far away but still inside the triangle. So in this triangle, that means the x minus 10 is going to equal the 60 plus the 70 added together. And if you were to solve for this, we would simply add the right-hand side. That's 130, and I'm going to add 10. And our unknown x is 140 degrees. So let me give you another example of that last one more time. Whenever you have an exterior angle, that would be this angle on the outside, it's going to equal the sum of the two angles that are inside the triangle but not touching that angle. They're called the remote interior angles. Remote means far away. Remote interior. So once again, the exterior angle, which is the yellow one, is equal to the blue plus the red. Samina, I hope this was helpful to you. Please email me or send me another text if you have additional problems.